Hello again, everybody, and welcome to another session of Sun Devil Learning Labs from Arizona State University. I'm your instructor, Michael Barker, and today we're going to be talking about how we add fraction, and we're going to make like units numerically. We're going to start getting away from just using our models and our pictures and starting to just do a little more with numbers. So before we start, I think, I'll remind you of that objective right now. Our objective is we want to add fractions, making like units numerically. The key here today is numerically. We want to start getting away from having to draw pictures. It'll get a little complicated when we get into fractions that have larger denominators and just multiple parts. So first, I'd like to make sure that you're in a comfortable setting with no distractions. We talk about that a lot. Little brother or sister, somebody's running around behind you, ask if they can move or if you can move to a quieter place. Make sure your dog isn't going to be barking in the background or that the TV isn't on, because it'll just distract from you. And it's going to be honest, it'll take longer to finish the lesson. Then second, gather any supplies you might need today. I'm going to suggest a couple of pencils, a notebook. I hope you're keeping a notebook for these lessons, or at least several sheets of paper. Scissors, maybe not so much today because we shouldn't be cutting any models out, but a ruler is always helpful if you want to draw some diagrams. And then be sure and use the restroom before we start. And remember, you can always pause the video if you need to take a break. So when we start, I'd like for you to solve each one of these expressions and write your answers in words as well as numerically. The first one is going to be done for you already, and I'll lead you through that. It's 2/5 plus 1/5 equals 3/5, and 3/5 written as a fraction is 3/5, numerator, denominator. And go ahead, take a couple of minutes. This shouldn't take you more than about 3 minutes or so. Write these down, and then we'll get together when you come back. Hey, welcome back. Okay, hopefully your worksheets look something like this. We did the first one, 3/7 plus 2/7. Should have got 5/7, hopefully. 3/4 plus 3/4. Well, that's going to give us 6/4. And you should have got a mixed number, 1 and 2/4. And if you really want to simplify our 2/4, that's the same as 1/2. So our answer would be 1 and 1/2. Although most of us will take 1 and 2/4 as well. 3/8 and 2/8, 5/8. 7/8 plus 1/8, that should be 8/8. And we know that anytime our numerator and denominator are the same, that gives us a total of 1. That's one whole unit. 2/3 and 6/3 is 8/3. And that's actually going to give us a total of 2 and 2/3. You should have been able to figure that out. 3/5 and 2/5, again, 5/5 is the same as 1. And finally, we went a little higher, 9/16 and 4/16. You should have got 13/16. And after that, we want to look at our first problem today, first part of the lesson. Problem 1, our friend Hannah ran 1/2 mile. On Tuesday, she ran 1/5 of a mile farther than Monday. How far did Hannah run on Tuesday? Okay, if we remember from word problem Wednesday, another thing is we don't really need to worry about how much Hannah ran on Monday. Our question today is, how far did Hannah run on Tuesday? Well, she ran 1/2 a mile, and then she ran 1/5 of a mile also. So we want to look at how we would solve this, and I'm going to use our area models one last time for this solution. And then hopefully you'll be able to figure out, and we'll look at it numerically as well. Hopefully you'll be able to figure out how to stop having to draw the pictures all the time, and we'll just do the math. But for now, we want to add 1/2 and 1/5. So we broke our first area unit into 1/2. And then what we did was we had to break that into more equal parts, right? When our denominator, figured out we needed 10 equal parts. And we wound up 1/2 was the same as 5/10. And when we drew our second part, we had 1/5 and we needed to have 10 equal parts. So we wound up with a grand total of 2/10. So we had 5/10 and 2/10 gave us 7/10. Our 2/10 the same as 1/5, 5/10 the same as 1/2. And by now you should be pretty quick at just drawing the lines and breaking the parts into pieces by yourself. But what if we didn't draw a picture? So we could use what we've worked with before, our lowest common multiple, right? Sometimes we're inclined to just say 2 times 5 is 10 and get the denominator. We're going to see later there's going to be some problems where that doesn't always work because the numbers can get really large. But in here, our lowest common multiple, what did we do? We said 2 times 1 was 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, and 2 times 5 is 10. And I stopped there because I kind of knew in my head that was the answer. 5 times 1 is 5, and 5 times 2 is 10. So we know our lowest common multiple is going to be 10. So we need to convert both our denominators to be an equivalent fraction that has 10 as a denominator. And that's what we do in our next step. We multiply 1/2 by 5 over 5, and 1 times 5 will give us 5, and 2 times 5 gives us 10. And then 1 times 2 is 2, and 5 times 2 is 10. We got these numbers right up from our lowest common multiples, and they both gave us a denominator of 5/10 and 2/10. I hope you can see all of that, and we didn't have to draw a picture. That was probably one of the more important things. I left the picture up here so we could illustrate a little bit what we were adding, but we did it by just using our numbers. So then when we get to the next step, we take our 5/10 and our 2/10, and our solution is going to be 7/10. Our screen is getting a little, there we go. Our solution is 7/10. And finally, we learned on Word Problem Wednesday, and specifically anytime we get asked a question and it's written like this, we probably want to give our answer in a complete sentence. We can write a number sentence like we did with 5/10 plus 2/10 plus 7/10, but then we should also answer that in a sentence that we can just write out. And in this case, it would be Hannah ran 7/10 of a mile on Tuesday. Hopefully that all makes sense, and it should have worked. Again, I'm not saying don't draw your area models or use your fraction bars if you really need to rely on them. But hopefully as we're progressing, we can start just working with lowest common multiples and working numerically a little more. So we'll move on to the next problem. And now our friend Hannah is baking 2 cakes. She uses 1/2 cup of flour in the first and 2/3 of cup in the second. So the question is, how much flour did Hannah use? Well, it's pretty simple, right? Or it should be for us. 1/2 of a cup and 2/3 of a cup is going to tell us that what the total amount of flour that Hannah used. And we also know from previous lessons that our answer will be greater than 1 because both fractions are greater than 1/2. Hopefully you realize that if it's greater than 1, we're going to have an improper fraction that we can make into a mixed number. So now, when we look at this, we can go for greatest common multiple. And really, 2 times 3 equals 6. It's the same as 3 times 2. When our new denominators are this small, a lot of times what we can do is just multiply the denominators and still have workable numbers. And that's exactly what we do here. We have 1/2 times 3/3, and that will give us 3/6. And 2/3 times 2/2 will give us 4/6. So the next thing we need to do is add, my pointer keeps pushing us out of the way, but at the bottom you can see we add our fractions of 3/6 plus 4/6, and that's going to equal 7/6. Now we know the 6/6 is the same as 1, and then 1/6 will be what we have left. So our final solution is going to be 1 1/6 as a mixed number. So I'm sorry, we'll go back to this part. And that will, all we have to do now, we can look at our solution there, and we know now that Hannah used 1 1/6 cups of flour to make 2 cakes. That's how we write our sentence out in words. That's our solution in words. We had our number solution, but we also use a sentence because, again, our question was asked in sentence form. Okay, we're back. And now Hannah and her friends decided they wanted to share some of those beautiful cakes that she made. And they didn't eat all of the cake, though. They ate 5/9 of the first cake and 5/6 of the second. So our question today is, how much cake did they eat all together? So we know 5/9 we would express as a fraction of 5 parts of 9. And our second part, they ate 5/6 of the second cake. So 5 out of 6 parts is what they ate there. So now we want to know, and we don't want to draw a model. We're going to try and solve this numerically. And we want to make our denominators the same. We know we have to be comparing the same number of parts. We don't want to look at 9. We don't want to look at 6. They just don't work. We can't add those fractions. And we really don't want to try just multiplying. That gets into a pretty big number. Sometimes that's what we need to do, but 6 times 9 is 54. Let's check and see what our lowest common multiple might be. So our first denominator is 9 whole parts. So we look and I see 9 times 1 is 9. 9 times 2 is 18. And then 9 times 3 is 27. And that's as far as I'm going to go for now. Our second denominator is 6. And we just try to find multiples of 6. We have 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. You might also notice that what we're doing in both of these is skip counting. Every time we go up, we just increase by the previous number, right? 9, 18, 27, or skip count here, 6, 12, 18. That's just another tool we can use to help find that multiple. But here, now I've highlighted 18 is a multiple of 9 and a multiple of 6. So we can agree that we're going to now change our denominator and our total number of parts to 18. And how do we do that? We set up a problem over here. We know that 9 times 2 is 18. So we're going to take 2 times 2. That's the same as 1, or 2 over 2, I'm sorry. 2 times 5 is 10. 2 times 9 is 18. So now we have 10 parts of 18. 10 parts of 18 is what we're looking for, a number with 18 parts. We go back to our multiples. 3 times 6 is 18. So we're going to multiply our fraction by 3 over 3. That will give us a total of 15 over 18. And now we've determined that both of our fractions are equivalent to each other, but in terms of 18 parts. So finally, we get to the solution. We have 10 18ths plus 15 18ths for a total of 25 18ths. And we want to deal with those 25 18ths one more time. So 25 18ths can be broken down into 18 18ths. That would be our whole, right? Plus 7 18ths, or 1. That would be 18 18ths is 1, and 7 18ths. And finally, we want to answer the question in a complete sentence. And we can say, Hannah and her friends ate 1 7 18ths of the 2 cakes together. Let's move on and see what else Hannah might be up to. Well, let's just consider this. What if she had 3 cakes? What if Hannah had baked 3 cakes and she was sharing parts of all three of the cakes. In this case, 2/3 of one, 1/4 of another, and 1/2. Would that affect how we add our fractions, or do we still have to have a like denominator? We want to work with units that are in the same parts. But we know how to do that now, and we know how to do that numerically. So first thing we'll do is we're going to look for our lowest common multiple, right? So 3 times 4 is 12. And then if we look at our second cake where they ate 1/4, we know 4 times 3 is 12. And then finally, our last cake was half, but we know 6 times 2 is 12. So now we know how to convert all our fractions into units with like terms. And then we'll be able to add them. So the first step is we got to make everything have like terms. So 2 over 3, 2/3, times 4 over 4 is equivalent to 8 over 12. Our second fraction, 1 over 4, we're going to multiply by its multiple of 3 over 3. And we get 3 parts of 12. And then finally, 1/2, we're going to multiply by 6 for our multiple. And we wind up with 6 parts of 12. So now you can see we have 6/12, 3/12, and 8/12. And we're working with all the same units. And I simplified it here. We had 8/12 plus 3/12 plus 6/12. We know our denominator stays the same at 12, but we're going to add 8 and 3 and 6 for a total of 17. And 17/12 can now be simplified to 12/12 plus 5/12. Or we know 12/12 is the same as 1. So 1 and 5/12 is our solution numerically. And if we were going to write our answer, it would be Hannah and her friends ate 1 and 5/12 of the cake. And now it's going to be your turn. I want you to try and solve numerically using the lowest common multiple. It's still okay to use the area models if they help. You're working on your own. Or if you have a partner that's studying this with you, I recommend that sometimes as well. And I'm going to do them myself at home, and then we'll compare solutions in about 10 minutes or so. Okay? Take a break if you need to, and then start working on these, and we'll do a couple at a time. Okay, we're back. Let's look at our solution for the first two problems. I split them up into two sides of the board. And hopefully your solution looks something like this: 3/4 plus 1/7. If you did a little work here, you would know that they're going to have their multiples. 4 times 7 is 28. That you can just multiply the denominators. That's the lowest common multiple that they're going to have is 28. So we know we need to multiply 4 times 7 and 7 times 4 to make our fractions equivalent units. So in this example, we had 3/4 times 7 over 7, which would give us 21 parts of 28. The second part, we took 1/7 and we multiplied by 4 parts of 4, and we came up with 4 parts of 28. We take our two solutions, 21 parts of 28 and 4 parts of 28, and hopefully you got 25 parts of 28. And that should have been a solution for this first problem. Your work may look a little different than how I did it. Maybe you skip steps, maybe you add steps or use a model. But at the end of the day, hopefully that you realize we have to start talking about 28 parts. And when we do, our equivalent fractions tell us this is our solution, 25 parts of 28. Okay, we'll look at our second problem. And it was 1/4 plus 9/8. So that's already an improper fraction. Let's see what happens here. Well, our lowest common multiple is 8. And what does that tell us? Well, 8, we've already got 1/8, so that's good. We don't have to do anything with 9/8. And then 1/4, we know that 2 times 4 is 8, so 1/4 times 2/2 is going to be 2/8. So we want to wind up adding 2/8 to our 9/8, and you should have gotten a total of 11/8. Now 11/8, again, improper fraction, but we can make it into a mixed number because we know that 8/8 is the same as 1, and then we'll have 3/8 left over. So our improper fraction is 11/8, and our mixed number is 1 3/8. Hopefully your solutions look something like this. Let's move on to the next two. We had 1/5 plus 2/3. We looked at that and we found our lowest common multiple in this case was going to be 15, and it happens to be the same as 3 times 5. So what we know is that if the lowest common multiple is 15, again, we want to express both our denominators and both our units as parts of 15. So first we say 5 times 3. So 1/5 times 3/3. That'll give us a total of 3/15. And then 2/3, we need to multiply those by 5. And that gives us a total of 10 units out of 15. So now we have the same number of units for both fractions, and we just have to add 3/15 plus 10/15, and hopefully that should have given you a solution of 13/15 for this problem. And now we'll move to 3/4 plus 5/6. This was the fourth problem you were assigned. And you'll notice the lowest common multiple is 12. And if we would have done 4 times 6, that would have been 24. So it behooved us, right, to find a lower multiple. And hopefully in your work, whether it's on your note sheet or if you just did it on the side, you should know that 3 times 4 is 12. So, and 2 times 6 is 12. So now you'll be able to reduce both unit fractions into 12ths. You start with 3/4 times 3/3, and that gives us a total of 9/12. Then we have 5 times 2, 10, and 6 times 2, 12. So we have 9/12, 9 parts of 12, plus 10 parts of 12 gives us 19/12. 19/12. I hope you took the next step and simplified this or reduced it to a mixed number. We have 12/12, same as 1, and 7/12. So hopefully you came up with a mixed number of 1 and 7/12. And finally, our last three problems. And this is where we worked on adding more than more than 2 fractions, because we can do that. We just need to, again, to remember to reduce them all to the same denominator or the same number of units so we can compare them equally. So our lowest common multiple of the first problem, 1/2 plus 2/3 plus 3/4, is going to be 12. But so here we are. We have 1/2. We know 2 times 6 is 12, so we'll use 6 here. 6/6, that makes 6/12. And then we know 3 times 4 will give us 12, so we multiply 2/3 times 4/4. And that will give us 2 times 4 is 8, 3 times 4 is 12. And then finally 3/4, 3/4 times 3 times 4 will be 12. So 3 times 3 is 9, 3 times 4 is 12. So now we have all similar units. We have 6/12 plus 8/12 plus 9/12. And when we add 9 and 8 and 6, we should get a total of 23/12. 23/12 we can also simplify. 12/12 is 1. We know that, right? And then we're going to have 11/12 remaining. So we're going to wind up with a mixed number of 1 and 11/12. And this should be what your worksheet looked like, somewhat like this. Again, it doesn't have to be this, but if you want to copy this and take some notes, I would pause the video and that would be a good thing to do. Finally, we'll look at the last problem, and it was a little bit easy, but it could have been tricky if you thought you needed larger multiples. 2/5 plus 1/10 plus 7/10. Our lowest common multiple happened to be 10 because 2 times 5 is 10. We already have 10s in two of our fractions, so we really only need to work on one fraction. 2/5 times 2 over 2. I'm sorry, that should have been a 2 on my worksheet. That's wrong, but I hope you can see that 2 times 2 will be 4, and 2 times 5 will be 10. So that would give us 4/10 plus our 1/10 plus our 7/10. We have 4/10 plus 1/10 plus 7/10 gives us a total of 12/10. 12/10 we can change to 10/10 plus 2/10 or 1 2/10. Again, if you need to practice more, in our teacher guide, we always mention Khan Academy, and there are more resources, and there are a lot more problems that you can practice and work on, and come back to these solutions as reference for how to solve things. And I hope you had a successful session today, and if not, visit us again. We're going to have more sessions on adding fractions, and next week we'll also move into subtracting fractions.